Welcome back to the Deep Dive, everybody. Today, we're going deep on something that's been getting a lot of buzz in the machine learning world. Retrieval-Augmented Generation, RAG.
That's right. We're talking about those systems that don't just try to know everything, but actually go out and fetch specific information when they need it.
Exactly. And the paper we're looking at today digs into something really important about RAG, just how tough it is, how well it can handle all the weird stuff it might encounter out there in the real world.
You mean how robust they are?
Yeah, robust. That's the fancy word for it. So the paper is called Quantifying the Robustness of Retrieval-Augmented Language Models Against Spurious Features in Grounding Data. Bit of a mouthful, but bear with me.
What they're basically saying is sometimes RAG systems get thrown off by things that don't actually change the meaning of the information, but just how it's presented.
Right. Imagine you ask a RAG system a question, and it finds the perfect answer tucked away in some website. But then it gives you a totally different answer just because that website uses weird formatting or the sentences are all jumbled up.
Exactly. And that's what the researchers are calling spurious features. Things that don't change the facts, but can still mess with a RAG model's head.
And for anyone out there who's really serious about using RAG for, real-world applications, this is a big deal.
Absolutely. Because in the real world, the data isn't always going to be neat and tidy. It's going to be messy. And if your RAG system can't handle that messiness, well.
Yeah, it's not going to be very useful, is it? So let's get into what the researchers actually found. First off, they did confirm something that a lot of people already suspected, which is that our RAG models are surprisingly sensitive to these spurious features.
So they didn't just throw their hands up and say, oh, well, our RAG's broken. They actually came up with a really clever way to test and measure this sensitivity.
Right. And the first step was to come up with a system for categorizing all these different types of spurious features. They call it a taxonomy.
Taxonomy. Fancy word for a list. But it's a really important list because it helps us understand all the different ways a RAG model can get tripped up.
So they came up with 5 main categories. First, there's style, which is basically how complex or simple the language is.
Right. So think about it. One website might use really technical jargon, while another one explains the same thing in plain English.
Exactly. And then there's source, which is all about where the information came from.
Was it written by a person or generated by another AI?
Then we've got logic, which is whether the order of sentences affects the model's understanding.
Format is another big one. HTML, Markdown, YAML, JSON, all those different ways of structuring data.
And finally, metadata, which is timestamps, author names, stuff like that.
So that taxonomy gives us a pretty comprehensive view of all the things that could potentially throw a RAG model off course.
But they didn't stop there. They actually created a whole framework for testing how robust different RAG models are to these different types of spurious features. They called it SURE, which stands for
Spurious Features Robustness Evaluation. Catchy, right?
Yeah, real catchy. But seriously, it's a pretty cool system. Basically, they take a piece of information and then deliberately mess with it. They add in different spurious features, but they make absolutely sure that the meaning of the information stays the same.
So it's taking a recipe and writing it in all different fonts and colors. The recipe is still the same, but it might look totally different.
And then they test how well different RAG models can handle these altered versions of the information.
Right. They're not just looking at whether the model gets the right answer, but also how consistent it is across all the different variations.
Exactly. And they came up with a few different metrics for measuring this robustness.
There's the robustness rate, which tells you how often the model gives the same answer, even when the spurious features change.
Then there's the win rate, which is, when a change in a spurious feature actually helps the model get the right answer.
And of course, there's the lose rate, which is when a spurious feature trips the model up and it gets the wrong answer.
So they put a bunch of different language models through this whole SURE process. And what did they find?
Well, the results were pretty interesting. First of all, it seems like sensitivity to spurious features is a pretty widespread problem. It's not just 1 or 2 models that are affected by this. It's pretty much across the board.
And surprisingly, making the language model bigger didn't necessarily make it more robust.
Yeah, you'd think that a bigger, more powerful model would be less easily fooled by these little quirks in the data, but that's not always the case.
But one of the really interesting things they found was that sometimes changing a spurious feature actually made the model perform better. It would get an answer wrong with the original data, but then get it right when they, changed the formatting or something.
Right. And that raises some really interesting questions about like how we present information to these models. Maybe there are certain ways of phrasing things or structuring data that can actually help the model understand it better, even if the core meaning is the same.
So, to make things even more challenging, they created a special dataset called SIG, which stands for Spurious Features in Golden Document.
Basically, it's a collection of really tricky examples where the models were most likely to be thrown off by spurious features.
And they used this dataset to really push the limits of these different language models and see how they handled the toughest cases.
Now, this research is really important because it connects to this bigger question of model robustness, which is something that's been a hot topic in machine learning for a while now.
Yeah, people have been trying to figure out how to make these models more resilient to all sorts of weird inputs and variations.
And with R, it becomes even more crucial because R models are constantly pulling information from the wild, wild west of the internet.
Where, let's be honest, anything goes. You've got websites with like a million pop-ups and flashing banners, and then you've got these like minimalist blogs with nothing but plain text.
And the way people write online is all over the place. You've got formal academic papers, informal blog posts, tweets, forum comments.
And our RAG models have to be able to handle all of that without getting thrown off by the way it looks.
Right. And this research is really pushing us to think more carefully about how we evaluate these models. Like, it's not enough to just look at overall accuracy anymore.
We need to start thinking about things like faithfulness and robustness and how these models perform in the face of real-world messiness.
Now, this research opens up some exciting possibilities for future research. One idea is to create what we might call spurious feature detectors.
Spurious feature detectors, what would those do?
Well, imagine a system that could look at a piece of text and say, hey, this formatting looks kind of sus. This might throw the ARG model off.
So it would be like a pre-screening process to identify potentially problematic features before they even get to the language model.
Exactly. And maybe it could even suggest ways to like normalize the text or re-rank the documents to minimize the impact of these features.
So the RGA model would be less likely to get tripped up by all the weird stuff it encounters.
Another really interesting direction is to try to design language models that are just inherently less sensitive to these spurious features.
Like build it into the model itself so it doesn't even matter how the information is presented.
Right. We could try to incorporate techniques from disentangled representation learning, where the goal is to separate the underlying meaning of the data from all the superficial stuff.
So the model would be able to focus on what the text is actually saying, regardless of the font, the color, the formatting, all that jazz.
Exactly. And that would be a huge step towards building more robust and reliable RGA systems.
So to sum it all up, the big takeaway here is that while RAG has a ton of potential, we need to be aware of these subtle vulnerabilities and keep pushing to make these systems tougher and more resilient.
This research is a great step in that direction, and it gives us a lot to think about as we continue to develop and deploy RAG in the real world.
The link to the full paper is in the show notes if you want to dive into the nitty-gritty details.
And before we wrap up, here's a question to ponder. As we become more and more reliant on AI to process information, how can we ensure that these systems are truly robust, not just to the obvious errors and biases, but also to all the subtle, hidden quirks of human language and data?
Food for thought, folks. Thanks for joining us on this deep dive into the fascinating world of ARG and model robustness. We'll catch you next time.